Hey everyone, Mr. Voikin here. This is Unit 7, Lesson 8, and we're going to be looking at function notation. So far we've been looking at how to map things out using graphs and ordered pairs and table of values, etc. But now we're going to look at the equation in a format called function notation. So we're not going to use this format right here, the mapping notation, but we will be using function notation and the equation of a graph of a function, and that's the one we've been using to this point. So y equals 2x plus 3, and then we tell you that x is equal to 5, so we replace that x with 5, and then we do the math and come up with the answer that y equals 13. So that's basically saying that when x is equal to 5, what is the value of y? And that equal sign that's there is really important. So basically, whatever's on the right has to be equal to whatever is on the left. Okay, so function notation just looks a little bit different, but it's the same thing. We're going to see it looking like this. F of x equals 2x plus 3. And rather than telling you that what is y when x is 5, they're sort of just going to take that x that's inside the bracket and they're going to put a 5 in there. So they're basically saying that f of 5 is the same thing as y. If you look right over here, it's basically, oops, not that one. That one, if we look straight across there, it's the same thing. Instead of saying y equals 2 times 5 plus 3, it says f of 5 equals 2 times 5 plus 3. So f of 5 is the value of the y when the x is replaced with a 5. So if it said f6, it'd be 2 times 6 plus 3. If it said f negative 8, it'd be 2 times negative 8 plus 3. And obviously in both situations, we come up with the same answer. So let's go take a look at the class example number 1. It says that we have two equations. Okay, we have f of x that equals x squared plus 5, and we have another one called g of x, which equals 4 minus x. So when we look at part A right here, it says f of 3. So in that case, I would use this equation because that is the f of x equation versus the other one, which is g of x. So remember, the way this can be laid out is just f of 3 equals, and what I would do, just so you don't make any mistakes, is wherever that x is over here, just put a bracket and then put that number in there and then replace everything else in there. That's going to help when you're inputting things into the calculator. Let's see, yeah, so when we get to part C, you'll see what I mean. Okay, so in this case, what do we do? Well, we just go 3 times 3, because it's 3 squared, is 9 plus 5, and that just equals 14. Okay, so the value of f of 3 is 14. Too easy. Okay, now the next one says g of 1. So in that case, we're going to have to use this other equation over here. G of 1 equals 4 minus, now again, just take brackets and put it around this x and put a 1 in there. And again, you'll see why later when we get to part D right here. Now this can just be input into the calculator as well, exactly as you see it. So it's like 4 minus bracket. We don't need the brackets, but it's still not going to affect anything, and it might just be easier for you and you'll make less mistakes. So the answer here equals 3. Okay, so I told you when we got to part C that you would sort of, I would sort of be able to explain why I am putting the brackets around the x. Okay, so in this case, we're going to use the f of x function. So it's going to be f of negative 2 equals, brackets squared plus 5, and inside here I'm going to put a negative 2. Now, what happens is if you use your calculator and you just go negative 2 squared, you can see that the answer right here is negative 4. But that's not the answer, because negative 2 squared means negative 2 times negative 2. And a negative times a negative is a positive. So that's why if we put a bracket there, then the negative 2 inside, and then square it, then it actually turns out to be the correct answer, which is 4. Okay, so I would right here make sure that I lay it out like that with the brackets, and now all I have to do is punch it in exactly. So whatever's on the right hand side, I just have to punch that in exactly as I see it on the calculator. Then there's 0 mistakes. Bracket negative 2, bracket squared plus 5, enter, and the answer is 9. Okay, and let's move down to part D, and we've got g of negative 2. So if I go g of negative 2 equals 4 minus bracket, bracket, and I put the negative 2 in here. So this is why, again, I'm saying putting the brackets there, you're going to make less mistakes, because you can see here that I've got a minus negative 2. So I have 2 negative signs there. And really what that means, that would be the same as 4 plus 2. So the answer should be 6. But what students do is they see that negative 2 there, and then they end up just writing it sort of like this, where they're going to say g of negative 2 equals 4, and then they see the minus in the equation, and then they just put a 2 right there because they can see like a minus 2, same as that one right there. But again, that would give you an incorrect answer. So it's going to be 4 minus the brackets, put the negative 2 in there. Now again, once you get to this point, you just need to take whatever's on the right hand side and punch it into the calculator exactly like you see it. So this would be 4. Now this is the minus sign right here on the calculator to the right, and the other one's a negative. So this is the operation right here, which is going to be minus, and this is the assignment that's telling us if that number is positive or negative. Okay, so this is a negative. So it's 4 minus negative 2. Okay, now when I punch that in the calculator, I need to go 4 minus, that's this one, bracket, negative down here, 2, bracket, and you can see the answer is 6. I don't think it works if you press minus, bracket, minus 2. So let me just check. So 4 minus bracket minus 2 bracket, oh, still works in this case. On the actual TI-84 calculator, when you're trying to punch in equations into the y equals graphing part of your calculator, it won't accept these minuses right here. But on this online calculator, it does. Okay, so let me just reduce this down. Hope this is all making sense. Okay, now part E looks a little weird, but basically what it's saying is find the answer for f of 0, find the answer for g of 0, and then subtract the two from each other. Okay, so the first thing we're going to figure out is what is f of 0. So f of 0 equals bracket, bracket squared plus 5, 0 squared. I know that 0 squared is 0, so 0 plus 5 is 5. Okay, so really the answer to this part right here is 5. Now it's going to be minus whatever g of 0 is. So g of 0 equals 4 minus bracket, bracket, put a 0 in there. 4 minus 0 is 4. So up here, this is going to be g of 0 has a value of 4. So that statement there is saying what is 5 minus 4? Well, the answer is that it equals 1. 5 minus 4 is 1. Okay, let's take a look at this class example number 2. And then remember, this is all in your book on page 466. It says, consider the function f, and we have f of x equals 5x cubed minus 2x. And this comma just tells us that x is the subset. This is the symbol for subset of all real numbers. So that basically means x can be negative, positive, whole number, it can be a fraction, it can be basically any value that exists on the number line. Okay, so it tells us, well, what is f of 3 in part A? Well, we just went over that. So basically, I'm just going to go f of negative 3 equals, and remember what I told you to do? Go 5 bracket bracket cubed minus 2 bracket, and inside those brackets you're going to put a negative 3, and now it's just a calculator exercise. So it's basically, in this case, about setting it up properly. So if I clear this and I just say 5 bracket negative 3 bracket minus 2, hold on, forgetting the cubed. Let's clear that out. Try this again. 5 bracket negative 3 bracket. Now to do a cubed, you see there's no cubed over here. There's a squared button, but you hit this little hat symbol here. This little upwards arrow, and it allows you to put in a cubed. And now it's going to be minus 2 bracket. There's a negative 3 inside the brackets. And I believe, was that squared? No, it's just like that, and you can see there's our answer of negative 129. Negative 129. Okay, the second one is basically the same thing, it's just written a little different. The first one was f of negative 3. Now it tells us what is the value of f when we assign the value of 2 to the x, and it's the same thing. Just go f of 2 equals 5 bracket 2 cubed minus 2 bracket 2 bracket, and punch it in the calculator. So again, it's going to be 5 bracket 2 bracket cubed and minus 2 bracket 2 bracket, enter, and the answer is 36. Now, I recommend that you try and do these calculations by hand as also, and see if you come up with the same answer on the calculator. So here it just says the image of 7 under f, just another fancy way of writing the exact same thing that we've been doing. What is f of 7? And that equals 5 times bracket 7 cubed minus 2 bracket 7. I'm not going to punch that in the calculator because at this point you can do that yourself. Let's move on to part, what says C and then goes to E. I guess we're skipping D. So part E down here says write an expression for f of a. And the reason they're saying an expression is because we can't calculate anything when it's just an a. So just create an expression for that one. So basically it's going to be the same thing. What is f of a? Well, it's going to equal 5 times a cubed minus 2 times a. So if we write this out the way it is, it's basically done right there, but it would also be fine to go 5a cubed minus 2a. Okay, and the last one says, again, write an expression. So like I said in the last one here, we couldn't really calculate a final number because we don't have a value for a. Okay. And now what I'm going to do is I'm going to look at f, and it says the expression of f of 2 of x. So notice that on part E, I just took a and replaced the x's with an a. So now we're saying f of 2x. It's sort of weird, but we're gonna just take what's inside that bracket and put it in the bracket. So again, set it up like I showed you. F of 2x equals, well, what's the equation? 5 bracket bracket cubed minus 2 bracket bracket. So what are we going to put inside there? 2x. What are we going to put in here? 2x. Now, if we take this one right here, 2x, and I cube it, okay, so 2x is 2x times 2x times 2x. And 2 times 2 times 2 is 8. And x times x times x is x cubed. So what we really have here right now is 5 times this whole thing right here becomes an 8x cubed minus, now we can do some work down here. Basically, it's going to be minus 2 times 2x, which is going to be 4x. Okay, now I've got a little bit of work that I can still do right here. I can go 5 times 8x cubed, which is going to give us 40x cubed minus 4x. And in that case, we are done. Okay, let's move on to class example 3 here. It says we got p of x equals 4x squared minus 6x plus 1. And determine a simplified expression for p of x minus 3. So this one will be very, very similar to the one we just did right there. We're just going to replace all the x's with an x minus 3. Okay, so again, do this the way I showed you, which is writing p of x minus 3 equals 4 bracket bracket squared minus 6 bracket bracket plus 1. And in each side of these, inside each one of these brackets, we're going to write x minus 3, x minus 3. Okay, so again, we're not going to come up with a final answer. We're just going to sort of expand everything like we did in the last unit and sort of simplify it, put it all back together. So notice that right here, I have a squared, and we're just following BEDMAS, right? So are there any brackets? Yes. Can I do anything inside those brackets? Well, no, x minus 3 cannot be simplified anymore, so brackets are done. Are there exponents? Yes, there's a squared, so we're going to do that first. So we're going to look at x minus 3 times x minus 3. That becomes x squared minus 3x minus 3x plus 9, which is going to simplify to this 4 stays there, and now inside brackets right here I can write x squared minus 6x plus 9. And now, are there any more exponents? No, so that's done. Now I move on to division and multiplication. I'm just going to write this one out again. Minus 6 times x minus 3 plus 1. So I do have some division and multiplication. There's this 4 times everything that's inside there, and this 6 times everything that is right there. Okay, so let's go ahead and do that. Okay, so 4 on the first one, 4 times x squared becomes 4x squared. 4 times negative 6 is negative 24x, and 4 times 9 is 36. Okay, so I have that is my first part. From that, I'm going to subtract whatever the answer I get right here. So 6 times x is going to be 6x, and 6 times negative 3 is negative 18, and this sign here that is negative, it's best to change that to a positive and change the signs of everything inside there. So really what we end up with is minus 6x plus 18. And another way to do that is just to, instead of putting the minus here to begin with, we're just going to use the negative 6 and multiply it by each one of these in here. Okay, so I'm going to go negative 6 times x is negative 6x, and negative 6 times negative 3 is positive 18. Okay, so now I've got sort of that, and really what I need to do is take away this bracket at this point and take all of these terms that we have right here, and I just need to gather the like terms. So I'm just going to move it over, and we're going to put it in descending order, right? So the first thing I do is look for, well, what's my highest value? It's the x squared right here. That's the highest degree. Are there any more squareds? No. So I'm going to take that one. It's going to be 4x squared. That's going to start off first. Do I have any x's? Yes, I do. I've got negative 24x's right there and negative 6x's right here. And you can see that using color allows us to make sure that we're not missing these things, and it just allows us to visualize and think a lot better. So what do I have? I've got a negative 24 and a negative 6. So this is just, you have to have the skills to add and subtract integers, but again, you're allowed to use a calculator, or on the test, you're trying to get as many of these questions right as possible. So if you have to, it's just we're gathering them together, so we're adding them together. So it's like negative 24 plus a negative 6. Enter. So I got negative 30 x's. Okay, so we got minus 30 x's. And what about the constants? Do we have constants? Yes, we do. We have 36 of them here and 18 of them there. And if we put those together, we're going to have a plus 54. And that is simplified as far as we can go. Okay. Hold on. I'm back. I forgot something. This little guy. This little 1 that's hanging up here. Okay, we got to add that 1 in there. So I should have, I was just about to move on to the next question. I realized, hey, don't forget this 1. So we need to add a 1 to that, which would also be a constant. So that's going to change this from 54 to 55. Let me just erase that really quickly. Woo! Lucky. 55. Okay, there we go. Okay, moving on to class example 4. It says we've got a function f of x equals 10x minus 3, and x is a subset of all real numbers. In this one tricks students, because they see f of x equals 47 and they want to replace the x's with 47, but we're saying f of x equals 47. We're not saying x equals 47. And if you look at the question, it's saying what is the value of x? So that's what we don't know and what we're trying to figure out. So basically that 47 would replace that right there, the f of x. So if I was to rewrite that, remember f of x is equal to 47, so instead of writing f of x on the left side, I'm going to write 47 equals 10 times x minus 3. Now we're just down to basic algebra. I need to solve x. So I want to take the equal sign right here, and on one side I want numbers, and on the other side I want my variable x. So 10 is attached to x. It's like 10 times x. A little bit more difficult to separate the two. They're sort of holding on to each other. So let's go pick on lonely little number 3 there. So I've got negative 3. How do I get rid of it and make it 0? Well, I'm going to add 3 to it. And negative 3 plus 3 makes 0. But remember, we like doing everything fairly. So to be equal, if I'm adding 3 on the right, I need to add 3 on the left. And so what we end up with is 50 equals 10 times x. So it's basically saying 10 times what equals 50? Well, if I divide this side by 10, remember, I have to divide the other side by 10. 10 divided by 10 is 1. So, and that's what we're trying to figure out. What is the value of an x? What is the value of 1x? But we usually don't write the 1 right there. We just put the x. But it is 1x. And 50 divided by 10 is 5. Okay, now we can go through and check this by, remember, now we know that the x value is 5, or at least that's what we think it is. So I just need to go along and place it back into our original equation. So really what I'm doing now is going f of 5 equals 10 times bracket, 5 minus 3. And what was the value of f of x in this case? It was 47. So we're checking to see if what's on the right hand side equals 47. And if I punch that into my calculator, 10 bracket 5 bracket minus 3, enter, I get 47. Everything looks good. All right, so let's move on to part B. Oops. Looks like it's exactly the same, just negative number. So I'll put this up and over here. Okay, so really f of x equals negative 23. So again, what are we going to do? We're going to go, that means negative 23 equals 10 times x minus 3. And I'm just doing the same thing. Plus 3, plus 3. That gets crossed out. I have negative 23 plus 3. So I'm going to have a negative 20 equals 10x. Divide by 10, divide by 10, I get the value of x is equal to negative 2. So negative 20 divided by a positive 10 is a negative 2. Okay, and again, I just need to punch that back into my equation. So 10 times negative 2 minus 3 should equal negative 23 if I've done the math correctly. So I'm just going to punch that in the calculator. 10 bracket negative 2 bracket minus 3, enter. The answer is negative 23. The left equals the right, so we are right. There we go. Okay, last one, class example 5. We have f of x equals x squared minus 5, and it tells us that x can be the subset of all real numbers, so it's any possible number existing in our universe. So it says evaluate f of 4. So in this case, because the 4 is inside that bracket, we're saying that we replace all the x's with a 4. So let's do that. F of 4 equals bracket squared minus 5, and put a 4 in there. 4 squared is 16 minus 5. 16 minus 5 is 11. Part B. Solve the equation f of x equals 4. So this time we're not replacing the x with 4. We're trying to solve for x when we know that the f of x is going to be 4. So I'm going to replace the f of x with 4, and that equals x squared minus 5. So we're going to do the same thing that we did before. We're going to try and eliminate that negative 5 so that I'm left with only x's on one side and only numbers on the other side. So I'm going to add 5 to both sides. That gets canceled over here. On the left, we got 4 plus 5, which is 9, equals x squared. Now, if you some students again get tripped up on this one, but if with algebra, when I'm moving things left and right, or trying to get rid of things, or whatever we want to, whichever way we want to say it, You can see when it was a -5, we did the opposite. We added 5. When, in previous question, when it said 10 times x, we did the opposite of multiplication. We divided by 10. So this time I've got this squared that's being applied to the x. So what is the opposite of squaring something? It's taking the square root of something. And if we take the square root of x squared, becomes just x. Okay, but remember, whatever I do to one side, I need to do to the other side. What is the square root of 9? Well, it should be 3. And again, on your calculator, it's usually connected to this x squared button, and because it's a green, you have to press this second button to access that function. So second x squared, it brings up that symbol, and inside there I just want to hit 9 and hit enter, and the answer is 3. Okay, so x equals 3. Okay, part C says solve the equation. We know that f of t equals 75, and t is going to be greater than 0. Okay, so yeah, so I guess I should go back to part B right there, because x can be 3 or it can be -3. Okay, so the square root of 9 is a +3 or a -3. So sometimes we write it like this, positive -3. Okay, the most common one is the positive value. So that's what they're saying down in part C. They're saying, okay, figure out what the value of x is when f of t is going to be 75. Okay, and it says that t is going to be greater than 0, so it won't be the negative value. Okay, so let's just lay this out. So remember, our original equation was f of x equals x squared minus 5. I'm calling it f of t now. And we're saying that actually equals 75. So what is the value of x? What do we need to do? Well, same thing. We're going to add 5 to both sides, and that cancels, and I have 80 equals x squared. And what did I tell you to do? If it's x squared, we don't want to know what the value of x squared is. We want to know the value of x. And to remove the squared from the x, I want to take the square root of both sides. So I'm left with x equals the square root of 80. And it says leave it in radical form, so we don't want to put it in decimal form. So if I go here and go second square root of 80, and you can see that it comes up with an 8.9. But they don't want it in decimal form, rounded to whatever position. They want it in radical form, which is an exact value. So what we want to do is break this thing down. We want to start pulling out some values that are perfect squares. So I can rewrite this as x equals the square root of 4 times the square root of 4 times the square root of 5. So if you look right here on the calculator on the screen, 4 times 5 equals 80. So the square root of 4 times the square root of 4 times the square root of 5 equals the square root of 80. Okay, now what is the square root of 4? Well, the square root of 4 is a perfect square, so it's 2. And this is times times, so it's 2 times 2 times. Well, the square root of 5 is as simplified as we can go right there. And again, what is 2 times 2? It is 4, and we're left with 4 times root 5. We don't need to put a dot in between them. It's just 4 root 5. There we go. That's this unit all done, and here is your assignment. It's on page 467. Lots of fun questions to go through, and there's your answers right here on page 470. See you in class.